Okay, um, so now what the notes we've covered so far fall under 6.1 in your textbooks. So now this is going to be the start of 6.2. 6.2. So 6.2 involves two things: combining and transforming. Okay, combining and transforming. Combining, putting things together. Transforming means changing, right? So we're going to start with combining. When we're combining random variables, that means we're combining more than one sets of data. Okay, so if you look at the problems we've done so far, we had one table, right, for that problem. This problem we had one table, but I did it two ways, right? It's the same problem, but it's just done two ways. We really only had one table here. This problem here, we had one table, right? The one before that, we had one table, right? All of these problems just had one table. Now what we're going to be looking at is multiple tables, two or more. And what we're doing is we're combining those together, okay? So when we combine them, we look at this. So if I want to know the expected value of two lists combined, I'm going to take the expected value of one and add it with the expected value of the other. Makes sense, right? So if I get an average for one list, I'm going to combine it with the average of another list. Okay? If I'm taking the difference between the two averages, I'm going to take the expected value of one and subtract it from the expected value of the other table. Okay? Now, standard deviation is a little different. Standard deviation, variance, we rarely use. I always put it there just in case, but rarely do we use variance. It's mainly standard deviation. So if I'm combining standard deviations, notice how that one's different. This is always a plus in here. It's always a plus. It doesn't matter if I'm adding or subtracting, if I'm combining or finding the difference, right? You take the standard deviation of the first, square it. Take the standard deviation of the second table, square it, add them together, find the square root. Okay? Always adding in this one. This one depends on what we're doing. Are we combining them or am I finding the difference? Okay? So let's look at one problem. I kind of changed it up a little bit because it didn't make sense earlier. So the second table should be hot dogs as well. They both should be hot dogs. They both should be hot dogs. One was hot dogs and sodas, but it doesn't really make sense because how do you compare hot dogs and sodas? They're different, right? So you can't really find the average of two tables when they're different things. So these are both hot dogs. Okay. So this is hot dogs. Okay, so what this list is a list based off of two different places, two different minor league teams. Okay, one of them, the probability that they sell 100 hot dogs at one game is about 5%. The probability they sell 200 hot dogs is about 10%. The probability they sell 500 is 30%, and so on and so forth, right? The other team, the probability they sell 100 hot dogs is 10%. The probability they sell 200 hot dogs is 15%, and so on and so forth, right? Two separate tables, right? So what we're going to do is we're going to find the expected value for hot dogs when I combine them together, when I combine the list together, right? Because I can't really combine the list. Some of them have, like this one has 100 and this one has 100. This one has 200 and this one has 200, but then they start changing, right? So I can't really combine the lists that way. So if I'm going to combine the list, we'll say this is X and this is Y. So if I'm combining lists, I take the expected value for the first one and add it to the expected value for the second one. Find the average of one and find the average of the other, right? Use your calculators. What do you get? Point 3. 0.35. 0.1. 0.05. Okay, so for the first list, I get a average of 1,000. $10.25. Okay, let's see what I did. Let's see, 1,000, 5%, 210, 500, 30. Oh yeah, 30. 500 is supposed to be 30%, and 1,000 is supposed to be 35. And this one's supposed to be 35. Okay, let's see what I get now. $10.25. Okay. And what'd you do? What'd you guys get for the second list? 680. All right. So if I want to find the average of both lists combined, I just add up the averages of each. So total, you're going to get 1805. 1705. Thank you. 1705. Hot dogs. Yep. Okay. All right. So combined, if I wanted to combine both of these teams, they sell on an average night, they'll sell combined 1,705 hot dogs. Okay. Now, standard deviation is a little different. Standard deviation, we don't just add them. I have to do a little bit more besides add them. So the standard deviation of the first one, I got, what was it? 793, yeah. 4,793.016. So I got to square that. And then what was the standard deviation of the second one? 476.025. Perfect. Square that one, add them together, and then take the square root.
You guys get never mind, I did it wrong.
I got 924.98. Okay.
Thank you.
So be careful there, because a lot of times I see people just try to add them together. Add up 793.016 and 476.025. They'll try to add them up, and they're like, we did it for means. Standard deviation is a separate game. Standard deviation is a separate game. So anytime you're combining or finding the difference, this is what you're going to do. One standard deviation, square it. The other standard deviation, square it. Add them together, square root. Okay? Okay. Okay, so that's combining. The other one is scaling or shifting or transforming. Okay, you guys don't have this one? It's on the next page. Should be on the next page. Okay, this is the stuff that's also on the board. Okay, so transforming means changing, not combining. I'm not combining anything when I'm transforming. It's just changing, right? So the first one, I'm adding or subtracting a constant. C is a constant. I'm adding or subtracting a constant. Well, you take the original mean and you add or subtract that constant. Okay? That's like me saying this. That's like me saying, okay, for this one here, I'm going to add 50 hot dogs to each. I'm going to add 50 hot dogs to each. So I'm going to add 50 here, 50 here, 50 here, 50 here, and 50 here. Well, the mean would just get bigger by 50. You would just add 50. Or I'm going to take away 50. So this is 50. This is 150. This is 450. This is 950. This is 2,450. If I take away 50 from all of them, the mean's going to get smaller by 50, right? That's what that says. That's what the first one says. The second one, but standard deviation and variance won't change at all. If I add a constant to all of them, standard deviation will not change at all. Why doesn't standard deviation get bigger or smaller when I add a constant?
Because the distance between each point from the mean is the same.
The distance within is the same, right? Standard deviation measures spread, right? If I add 50 to all of these guys here, if I add 50 to all of these guys, are they getting any farther apart? No, they're not. Exactly. They're same distance away. There's no difference within. So that's why standard deviation stays the same. Same thing with variance. Okay. The second one is if I multiply it by what's called the scalar, multiply it by a number. So for example, I take all of these numbers here and I say, all right, I'm going to double each of them. So the first one's 200, the next one's 400, the next one's 1,000, the next one's 2,000, the last one's 5,000. If I double them, the mean is going to double as well. Okay, so the mean, instead of being 1,025 for the first table, the mean is going to be 2,050. Okay. Standard deviation and variance will also be multiplied because you're messing with the spread now. Okay. The old spread was 100 to 2,050. 2,400 spread, hot dog spread. If I double each of them, now the lowest is 200 and the highest is 5,000. The spread's getting wider. Okay, so if you're messing with the spread, that's when standard deviation will change. It won't change if you're not messing with the spread. Okay, and the bottom part's just what we just talked about. The bottom part is transform or combining. Okay, one thing though, in order for us to use the standard deviation formula that we used just 3 minutes ago, they have to be independent. They have to be independent. X's and Y's, the table has to be independent of one another. If they're not, then we cannot calculate it. We can't calculate it. We can't use this. Most of the time they'll tell you, they'll say they're independent. Okay. All right. So all this stuff is on the board here. What's that? Yeah, you just did it on the last test. Then we had a bunch of we had at least 2 questions that were checking for independence, right? All right.
A week after another
All right. Okay, so here we go. Let's do some practice problems here. Okay, so I have 2 lists. I have 2 tables. One is called X and one is called Y. They did a nice thing for you. They didn't give you the table. They just gave you what you needed to know. They said, okay, this table, if I find the expected value, if I calculate it, it's going to be 11. And the standard deviation is going to be 9. So there were 2 tables. But they're like, you know what? We're going to find the standard deviation and the variance for you and just give you the numbers. Okay? So there was a table. There were 2 tables. Right? So we have to answer these. What would the mean and standard deviation be if I took all of the X values and tripled them? Took all of the X values. So took the X table here and tripled each of them.
It'd be 27.
So what was the old? Well, let's go up here. That's a scalar. It's called the scalar. That's right here. It's this one right here. I took a number and multiplied each of these guys by a number. In this case, it was 3. So I'm going to take the old expected value and multiply it times 3. So expected value, the old one was 11. I'm multiplying it times 3, so the new expected value would be 33. Standard deviation is going to be exactly the same as, same process, I should say, not the same answer. Because the standard deviation, the old one was 9. The new one is, I'm tripling it, so it's messing with the spread. If I triple something, it's going to mess with the spread of the numbers. So that one's going to triple as well. So I get 27 for that one. Okay. Oops, I should put 3x here. Okay, so this one here. So I took each of the random variables and subtracted them by 15. I subtracted each of the random variables in the y table that they didn't give us, and I subtracted each of them by 15. By random variables, I mean these guys here. Like, for example, the random variables in this table are the hot dog sold. The random variables in this table are the hot dog sold. So I would subtract 15 from each of those. The random variables in this table here are the languages spoken, right? I don't have 15 to take away, but they would be negative, right? So like take 15 away from all of these guys. That's what I mean by take 15 away. You would be negative, right? It would be negative languages. Okay. So how do I find the new expected value? Subtract, take the old one, which was 24, and subtract it by 15, and I get 9. The new expected value would be 9. What about standard deviation? Does not change at all. Why not? Because the spread would be the same. The spread doesn't increase or decrease if I subtract everything by 15. It stays exactly the same. Okay. Letter C, I'm just combining, kind of like we did with the hot dogs. I'm combining them. So if I'm combining them, I take the expected value from X and add them with the expected value for Y, and we get 35, just like I did for the hot dogs. Expected value, or sorry, the standard deviation when I combine them is going to be a little different. So I'm going to have to take the standard deviation of the first one, 9, square it. Standard deviation of the second one, 5, square it, and then square root it. You're going to get a decimal, just round the decimal.
10.296.
Say that one more time.
10.2956.
2956. Okay. So 81 plus 25, and then find the square root. So what was it? 100? What is that? 106? Square root of 106. Okay. Letter D. Now I'm finding the difference between the two. So the first one was 11 minus 24. Well, my expected value is going to be a negative number. It's going to be negative 13.
Yep.
What will my standard deviation be?
The same.
The same as what?
The same as the other one. Because the process is the same. It doesn't matter if you're adding or subtracting.
Exactly. It doesn't matter if it's x plus y or x minus y. Your standard deviation is going to be exactly the same as square it, add them, square root. Okay. And then at the very top, they said they're independent random variables. So that's why we could use it. Okay. All right, what about this one? We got 3, now we're adding. So we're taking the first list, combining it with itself. What are we going to get? So we're just taking the first list and I'm combining it with itself. So I'm adding on top of each other, There you go. 11 plus 11 plus 11, which is 33.
So why is the same? Oh, because if you multiply it, then the standard deviation changes.
Let's see. So this one here, we got to take the first standard deviation, which was what, 9? 9, square that, Take the standard deviation of x again, 9, square that one more time, find the square root. So 81 times 8, 81 plus 81 plus 81 plus 81, square root. So 243, square root of 243, which is, what was it? Yeah, what was the square root though? When you took find the square root? 243, and then you get, say it one more time, Josh.
15.588.
That one is different than the one we did 3 times. So it's different. So even though you think, oh, x plus x plus x, that's 3x, it's not going to give you the same number because a standard deviation is not going to be the same. Expected value will be the same. Okay. F, we're combining them now. So now we're combining and we're transforming, right? I got to take, so what I'm going to do first is I'm going to do 5x. Yeah, I'm going to do 5x, right? It's just like regular, it's just like in math 1 or math 2, you did multiplication before you subtracted them. It's the same process. So I'm going to do 5x here, expected value for 5x. So that's 5 times 11. And then I'm going to do expected value for 3y, which is 3 times 24. 72. And then I'm going to subtract them. Negative 17. Now I have to do that same process, but with standard deviation now. So standard deviation of 5x is 5 times the standard deviation. Standard deviation of 3y is 3 times whatever the standard deviation was. So for x, the standard deviation was 9, y was 5. So I get 45 for this standard deviation, 15 for this standard deviation. Now there's a minus sign in the middle, so I'm not going to subtract them though. I can't subtract them. To find standard deviation of this, I have to use what I've used in the past. 45 square root, or sorry, squared, 15 squared, add them together, take the square root.
47.434.
So 45 squared plus 15 squared, add those together, take the square root, we get 47.434. Okay. Okay, so now we're going to use some of those. We're going to make tables now. So we didn't have tables in the last one. They gave us all the details. Now we have to make the table and then answer the question. Okay. So here we go. The Podunk Polar Bears is a football team. They have 2 games left in their season. So far they are winless. Experts estimate that the team has a 60% probability of winning the first game. If they win the first game, they have a 70% chance of winning the second game after that. Otherwise, they only have a 5% chance of winning the second game. So they want us to construct a probability model. Probability model means a table for the number of games they will win to finish the year. So games won to finish the year. How many games left do they have to finish the year? 2. So what are the possible, what's the sample space? What are all the possibilities of games won to finish the year? They could win 2, They can win one
or they win none.
or they win none. Okay, that's only things that could happen. They have 2 games left. They could win 0 of those games. They could win 1 of the games, or they could win both. Now what we're going to do is find the probability each of those happen. Anytime you're finding a table, making a table, again, go back to what we did in chapter 5. The 4 ways we did it was use the formulas, or, and or, two-way table, and or Venn diagram, and or tree diagram. Whichever one's easiest to use. So fill out the probabilities. I'll give you guys a few minutes, see if you guys can fill out those probabilities. What was the easiest way to find the probabilities, to fill out the table? Tree diagram. I use a tree diagram. Now, is there other ways? Yeah. But I think for this one, when it says one event, then the other event, when you have back-to-back events, I think tree diagram, it's like, and based off of one event, the other event, I think that's a kind of a textbook example of a tree diagram problem. Now, because it's only 2 events, so you might have been able to do all of the possibilities in your head. That would have been a little difficult, right? I wouldn't have tried that, but I'm just saying. Okay, so this is what I did. It said the first game they have a 60% chance, right? First game. So win loss, 60% loss. Now, if they win their first game, it said they had a 70% chance of winning the next game. That means a 30% chance of losing that game. And then if they lose the first game, there's a 5% chance of winning the second game, means a 95% chance of losing the second game. So there's only one path for 0 wins. 0 wins is the green, or sorry, the yellow on the bottom. This one here. This one is the only path for 0 wins. So 0.4 times 0.95 is 0.38. There's only one path for 2 wins. That's a win and a win. So 0.6 times 0.7, which equals 0.42. And then the last one, the middle 2 are 1 win and 1 loss. So 1 win. So games 1 is 1. So win, loss, loss, win. Either way, they finish out with the same outcome, 1 win. Okay. So making the table was completely chapter 5. That was 100%. We didn't do anything with random variables yet. Okay. Now what we're going to do here with this, we're going to do anything with it? Did it ask a question? No, it didn't. That's a chapter 5 question then. Yeah, I thought they were going to have us do something with it. Oh well. Okay, next question. It was good practice for chapter 5, yeah. Okay, so here we go. The die singular game. So one dice is multiple. Like if you have 2 dice in your hand, that's dice. If you only have 1, it's die. The singular game problem. You roll a die. If it comes up 6, you win $100. If not, you get to roll again. And if you get a 6 the second time, you'll get $50 this time. If not, you lose. I think it's just you lose. I don't know what that is. Formatting issue. I don't know. If not, you lose. Okay, that's the game. So let's create a probability model for the amount. So here's the random variable, the amount you win at this game. Okay, so I want you to do that one. I'll give you guys this one. We're going to do something with it, this table. We're not just making this table for fun. So how many different outcomes could happen in this game? 3 things could happen, right? In terms of winning. What are the 3 things I could have? I win nothing. I get $50. I get $100. Yep, I agree. Okay. So those are the three things, right? It didn't say how much you have to pay to play the game, right? So, and the question said winning. So we don't want any negatives in there. We want to keep it positive.
This is a game I can gamble on.
So what's the probability? How do I figure out the probability? So the easiest one I think is the probability you win $100. What 1 out of 6, right? I roll the die one time, I get a 6, boom, I win $100. That's 1 out of 6, which is about 1.167. How do I win $50?
5 out of 6 times 1 out of 6.
So on the first,
It's not out there.
I know, I'm not ready to show it because I have my answers up here. Okay, so the first one, what has to happen on the first one? Divided by, oops, my numbers were a little messed up. Plus 167, 1 minus that. Okay. So yeah, I had to have missed. To get $50, I had to have not hit 5, or sorry, 6, and then hit 6 on the next one. Well, what's the probability of hitting 6, not 6 on the first one? 5 out of 6. And then the next one is 1 out of 6, right? So 5 out of 6 times 1 out of 6 equals 5 out of 36. When you change to a decimal, is 0.139. And then the rest of the probabilities have to be losing, right? Losing means you don't get a 6 the first one, you don't get a 6 the second one. Here's my table. Okay. So on the first one, to get to not win, I have to get, it's 5 out of 6. There are 5 sides that I could get. Same thing over here. Multiply them together, you get 25 out of 36. 25 out of 36 as a decimal is right here. To win $50, you have to strike out on the first one, so the 5 out of 6 on that. And then on the second one, you have to hit it. You have to hit the 6. Multiply, you get 5 out of 36, which 5 out of 36 is 0.139. To win $100, you have to hit it on the first one. Wait, I'm missing something because that doesn't equal 1, does it? Does it equal 1? Okay. So 1 out of 6, which is the same as 6 out of 36, 5 out of 36, 25 out of 36. If you add them all together, you get 36 out of 36, which is 1 whole. Okay. All right, what would I expect to play? What would I expect to win on this? So let's see, expected value for this game. How much would I expect to win in the long run? Not the first time, not the second time, not the third time. If I sat and played 1,000, 10,000, a million times, how much would I expect to win each time on average? So the first one is $0 times 0.94 times 694. The next one is $50 times 139. The next one is $100 times 167.
About 2365 per game.
2365?
Yeah, hope so.
All right.
Can you get a fax?
That's it? Yep. Okay. So it didn't say how much this game should cost. But if you were in charge of putting this game on the casino floor and you knew these numbers, what should the casino charge? What's an acceptable amount that the casino could charge?
Above 23.65.
Anything above 23.65 to play for once.
23.6.
Anything above 23.65. If they charge $23.70 in the long run, they're going to make 5 cents every time, and you're going to lose 5 cents you're going to lose 5 cents every time, right? So anything above $23.65, that's what casinos know. That's how they figure out how much to charge. You know the differences between the slot machines. There's penny slots, nickel slots, dollar slots, 50 cents, quarter slots. How do they decide which one which? Well, they know the probabilities. And they figure if it's a 25-cent slot, in the long run, this number right here has to be lower than 25 cents, right? For the penny slots, that number has to be less than a penny because it has to be a fraction of a penny. In the long run, they got to win. Because if they charge anything less, they're losing money. That's not how casinos stay in business. If they do that, they're not going to be in business. Okay? So in order for this game, if you were going to play this game, you would have to charge someone above that to play. Okay? All right, so let's do... So now we're going to use the same table, and we're going to tweak it a little bit. I'm tweaking it a little bit every time. Same game we just played. Right? Roll a 6 on the first one, you get 100. Roll anything other than a 6, and then a 6 on the next one, you get $50. Roll anything other than a 6 on the first and the second time, you get nothing. Okay, so now what we're going to do is I'm going to tweak the game a little bit. I'm going to say, hey, I'm going to double the dollar amounts. So instead of 0, 50, and 100, it's going to be 0, 100, and $200 you could win now. Probabilities stay the same. How much would I expect to win if I did that? I'm just doubling, right? You're taking what originally was, right? You're taking the original, and you're multiplying it times 2. The original was $25.60, $23.65, and you double it, and you get $47.30. So if you're going to double the amounts, you would expect to win $47.30 in the long run. How do I do standard deviation? Well, we didn't find standard deviation of the last one, right? What was standard? It was on your thing when you calculated. What was it? 6. So if I double everything, yeah, that's a scalar. That means I'm multiplying. So I got to multiply 2 times the original standard deviation. So 2 times $38. So 76 something.
76.372.
372. Since it's money, we'll round. Last thing, we'll do letter C tomorrow. How about if I play the game twice? So original, go back to the original monies, 0, 50, 100. 0, 50, 100. But I play the game twice. Not once, twice.
So the median would be the same, but the standard deviation wouldn't. Then you're adding.
So without doubling the amounts stay the same. Aren't I taking 2 different lists? Aren't I taking 2 of these? No, don't I now have 2 of these? One for the first time and one for the second time? So, and I'm comparing, and I'm adding them, right? So this is kind of like we did earlier with X1 and X2. So now we're using combining, so we're adding them together. So still, yeah, it's $23.65 plus $23.65, which is still $47.30. Standard deviation, though, is going to change because standard deviation is the first one squared, so $38.38 squared plus 38,186 squared. That one's not going to be the same. Zero, zero, three. So we'll just say 54.00. Square it, add them, find the square root. Okay. Okay, so tomorrow what we're going to do is we're going to finish. There's two more problems. There's just two more problems and that's it. So we're going to finish that. We're not going to take all block to finish those two. So what I'm going to do is I'm going to print out the assignment from your book so you guys can get started on that. Okay.